Hello children, and welcome everybody to the class of science, and we have finished with this chapter number 13, magnetic effect of electric current. But still I want all of you to go through the pages of the book once again for this particular chapter, so that you will be very well understood with all the topics, and you will understand which topics are important. So here we go, chapter number 13, magnetic effect of electric current. And it starts with Oersted's famous experiment that a current carrying conductor produces magnetic field around it. So if you remember this experiment we did there, that when we keep a current carrying conductor, a battery is attached to the connecting wires and that is attached to the bulb, and when the current starts flowing through this small circuit, and if we place a magnetic needle there, we will observe that the magnetic needle gets deflected. And we all are aware that the magnet gets deflected only when we bring another magnet in the vicinity of this first magnetic needle. Oersted proved that a current carrying conductor produces magnetic field around it. And this invention is later on used for so many applications in the field of technology. After this, we discussed about magnetic field and magnetic field lines. And for this, if you remember, I told you about the bar magnet, and we discussed that the area around the bar magnet wherein the force of attraction is effective, that area is called as magnetic field. And magnetic field is very strong near the magnet, and as we move away from the magnetic field becomes weak. So this is how we discussed about the magnetic field, the strength of the magnetic field. And we also learned that the nature of the magnetic field around a bar magnet is in this manner. It looks like this, and the magnetic field lines, they start from North Pole and they merge at the South Pole. This is what we have learnt in magnetic field and magnetic field lines. If you remember children, we have also done an activity to actually see the magnetic field around a bar magnet. Then there was an activity wherein, when I say that the magnetic field lines, they emerge from North Pole and merge into the South Pole, and how it is proved. If you remember, we have taken this activity in the video lesson wherein I showed you as to how the magnetic field lines emerge from the North Pole and merge at the South Pole. Alright, and then we concluded that the magnetic field lines, they emerge at North Pole and merge at the South Pole, and the magnetic field lines are very close near the poles. And very important thing we understood, that the two magnetic field lines never intersect each other. Alright, so this is what is the main learning from this particular topic. Then magnetic field due to a current carrying conductor. So we studied about a straight conductor and a conductor which is in the form of a circular loop. But before that, I showed you, very short two experiments to understand the direction of flow of electric current. So for that, we took a simple circuit, and you can make out the direction of flow of electric current through this circuit from positive terminal to the negative terminal of the battery. That is the conventional flow of electric current. Now I have marked the direction as north, south, east and west. And looking at the direction of the flow of electric current, we can make out that the current is flowing from north to south. And suppose if I placed a magnetic needle over the wire, you can see that the north pole of the needle is deflecting towards the east direction. So this shows that the direction of flow of electric current and the direction of the deflection of the needle is the same. Now we had done the experiment just by changing the polarity. You can just check out that the polarity of the batteries are changed now. Again we will mark the directions as north, south, east and west direction. Alright. And then now you can just check out the direction of flow of electric current. It is from south to north direction. Now let's check out what is the direction of the deflection of the magnetic needle. So I'll place a magnetic needle over the wire and you can check out that the north pole is deflecting from south to north direction. So from this activity we concluded that the direction of flow of electric current and the direction of the deflection of the magnetic needle remains the same. Then we discussed about what is the nature of magnetic field around a straight conductor. So for that we took a straight conducting wire and we performed an activity. So we made a small circuit wherein we made use of a battery and a plug key, and we took a cardboard, make a hole at the center of the cardboard, and the cardboard was attached to the circuit in this manner. You remember this? And the moment we plug in the key there, we observed that the current starts flowing through the circuit in this manner. This is the direction of flow of electric current, and at the same time we could see some changes there on the iron filings which are sprinkled on the cardboard. The iron filings start arranging themselves in a particular manner, and if you observe that particular manner, the pattern if you observe, we could see that they arrange themselves in the form of concentric circles in this way. Alright, so we concluded that the magnetic field around a straight conductor is in the form of concentric circles. The circles are very close to each other near the conductor, and as we move away from the conductor, the circles are far apart from each other, because the strength of the magnetic field decreases as you move away from the conductor. Alright children, then we studied that the direction of magnetic field around a straight conductor can be found by using right hand thumb rule. And right hand thumb rule states that if you hold the conductor in your right hand in such a manner that the thumb is pointing in the direction of flow of electric current, then the curved fingers will always gives us the direction of magnetic field. So here you can see that the magnetic field, the direction of magnetic field is around the curved fingers, in the direction of the curved fingers. So this is all about right hand thumb rule, and in the textbook you can just see this particular figure as well. Then we discussed about magnetic field due to a current through a circular loop. So if the conductor is not a straight conductor but it is in the form of a circular loop. So consider this as a circular loop. We have taken kind of little oval loop here, and here we understood that at every point, though I have taken only 2 points, but we will observe that at every point on the circular loop, we will find the magnetic field in the form of concentric circle. Alright, and we will observe that at the center of the circular loop, the magnetic field lines are straight. It looks as if these are straight line. You can just observe there. Second observation is each segment of the loop carrying current produces magnetic field lines in the same direction within the loop. So on the loop, I take any point, it will produce the magnetic field in such a manner that it is in the same direction inside the loop. Alright, and then the direction of the magnetic field at the center of the circular coil is always perpendicular to the plane of the coil, that is along the axis of the coil. Alright children, so all these points we have studied in the video lessons which you have seen earlier. This is just a kind of revision through the textbook, because when you open the textbook you should know what all topics how we have covered. Then I told you that we have seen one activity also related with the circular loop. For that we took a cardboard and made 2 holes like this to the cardboard. Then a thin copper wire of many turns we had taken through these 2 holes, so it looked like this, and the 2 ends of the copper wire were kept free so that we can connect a battery to the 2 free ends. So the moment we connect the battery, current starts flowing through the copper wire and we could observe the pattern of magnetic field like this. So like I said, at every point, so we have taken 2 points like this, and at these 2 points we can make out that the magnetic field looks like concentric circle. So you select any point on the circular loop like this, everywhere we will observe concentric circles, and these circles as they reach at the center of the loop, it looks as if it is a straight line. Alright, and the direction of magnetic field here also can be detected by using right hand thumb rule. Alright children, after this we discussed about magnetic field due to a current in a solenoid. An important topic, I said, because in question paper many times question based on solenoid is always asked. So it is a coil of insulated copper wire which is in the form of a cylinder like this, that is called as solenoid, and the magnetic field in a solenoid is very strong magnetic field, because every loop is increasing the strength of the current and therefore increasing the strength of the magnetic field also. So we observed that when we pass current through this solenoid, it produces magnetic field around it, and very important thing we understood that at south pole the current flows in the clockwise direction. So when you are given a figure of a solenoid along with the battery connected to it and you are asked mark the north and south pole of the solenoid, keep this in mind that the direction where the current is clockwise is your south pole, and at north pole the current flows anti-clockwise direction. So this is how you can find the north and south pole of the solenoid. Very important thing we observe that the magnetic field around a solenoid resembles the magnetic field of a bar magnet. So you can see both the magnetic field exactly looks similar, and so we can say that the magnetic field of a solenoid resembles magnetic field of a bar magnet. Then a very important thing that inside this solenoid there is a free space, and there if we keep a steel rod or if we keep a soft iron core there and pass electric current through the solenoid, we will observe that we can magnetize this steel rod or we can magnetize this soft iron core, and that is called as electromagnet. So this is the use of solenoid, that we can make electromagnet with the help of the solenoid. Alright children, so we will stop here for the book part today. The remaining part of the book we will take in the next video lesson, but before that just have a look at this all important questions. These all questions have already asked in the previous year's exams of CBSE board. Please go through the questions. These are all, sometimes it is repeated also. I want all of you to check out the answers of all these questions, solve it, write it in your notebook, so that it will be a good practice to all of you. Alright, so the remaining part of the lesson we will see in the next video lesson. Until then, bye and take care children.